Welcome to the deep dive. Today, we're going to be taking a look at something you probably use every day without even realizing it. Google's Chubby lock service.
Oh, yeah.
We got this academic paper called the Chubby lock service for loosely coupled distributed systems. And let me tell you, it's way more interesting than it sounds.
Yeah, for sure.
This paper is basically the blueprint for a system that helps power some of Google's biggest products like search and Gmail.
Yeah, it's pretty wild to think about, right? Something so fundamental to how Google works is just tucked away behind the scenes.
Totally. So today we're going to break down what exactly Chubby is, why it's so important to Google's infrastructure, and uncover some surprising facts about how its use has evolved over time.
Right.
By the end of this deep dive, you'll have a whole new appreciation for the hidden complexity behind the seemingly simple things you do online every day.
Absolutely. And it all starts with understanding what Chubby is at its core.
Right.
It's a lock service, which might sound a bit cryptic, but it's actually a pretty simple concept. Think of it like this. You have a bunch of computers all working together as part of a distributed system.
Mm-hmm.
That's how Google operates, spreading out its data and processing across tons of machines. Now imagine all those computers need to access and modify the same data simultaneously. That's where Chubby comes in. It acts like a traffic cop, making sure only one computer can change a piece of data at a time, preventing conflicts and keeping everything running smoothly.
Okay, that makes sense. But why is that so important? I mean, couldn't they have just built something else that does the same thing?
Well, they definitely could have. But Chubby's real strength lies in its reliability and availability.
Okay.
For a company like Google, even a few minutes of downtime can translate to millions of dollars lost and unhappy users all over the world.
Oh, wow.
So they needed something that was virtually bulletproof, something that almost never fails and is practically always accessible.
Right.
That's Chubby.
So it's like a super reliable traffic cop that never takes a break, right? Always on duty.
Exactly. And even though it's often compared to a file system because it can store small amounts of data,
Right.
its primary function isn't storage. It's all about managing access to that data, ensuring consistency across Google's entire distributed system.
All right, so it's a lock service that's super reliable and ensures data consistency across Google's massive network of computers.
Got it.
But Google has tons of brilliant engineers.
Yeah.
Why build something like Chubby in the first place?
Yeah.
What specific problems were they trying to solve?
Great question. One of the key problems they needed to address was something called primary election.
Okay.
Imagine a scenario where you have a group of servers and one of them needs to be the leader, the one making the decisions.
Right.
Chubby helps determine that leader, reliably preventing conflicts and ensuring smooth operation. Think of it like a super fast and incredibly accurate election process, but for servers.
So it's preventing server anarchy, basically.
Pretty much. And beyond leader election, there's the crucial issue of data consistency. With countless computers accessing and modifying data, you need to ensure that everyone is working with the same up-to-date information.
Mm-hmm.
If you've ever lost an email or had a duplicate order online, you've experienced the consequences of data inconsistency.
Right.
Chubby is designed to prevent that by ensuring every computer in the system is on the same page.
So no server is left behind data-wise.
Exactly.
Interesting. What else does Chubby do?
Well, it also plays a key role in simplifying how different programs within Google's system share information.
Okay.
Think of it as the central bulletin board, where programs can post and retrieve important bits of data.
Gotcha.
It's a fast, efficient, and reliable way for these programs to communicate and stay synchronized.
Okay, so we know WHY, it's important. But how does this magic actually happen? Let's look under the hood.
Sure. One of the key concepts is replicas.
Okay.
Imagine multiple copies of Chubby running simultaneously. If one copy fails, the others seamlessly take over. This redundancy ensures that the system is incredibly resilient to failures.
Makes sense. Redundancy is crucial when you're dealing with services used by billions of people, right?
Absolutely. Now, among these replicas, there's always one master replica making the decisions with the others following its lead. It's a hierarchical system designed for efficiency and stability.
And then there are the clients, which are basically the programs that actually use Chubby.
Yeah.
They request locks, read and write data, and generally rely on Chubby to keep things running smoothly.
That's right. And here's where it gets interesting. There's this fascinating way Chubby is used that even its creators didn't initially anticipate.
Oh, this is where things get really interesting.
It sure is. You see, while Chubby was initially designed as a lock service, it accidentally became a popular name server within Google. It turns out that it became a sort of dynamic directory that helps different parts of the Google system find and communicate with each other instantly.
Okay.
Let's say a Google search server needs to talk to a server that stores user profiles. Chubby acts as a directory, providing the search server with the exact location and information it needs to connect with the user profile server.
Ah, I see. So it's not just controlling access to data, but also helping those different pieces of Google's infrastructure locate and connect with each other.
Precisely. And it turns out this was a game changer for Google.
Oh, really?
You see traditional internet name services like DNS,
Hmm.
the system that translates website names like google.com into IP addresses, rely on time-based caching.
Okay.
This means that information about where a particular server is located is stored for a certain amount of time. But when you're dealing with a system as dynamic and complex as Google's, with servers constantly being removed and updated,
Yeah.
that kind of caching can get bogged down and inefficient.
So Chubby's name server capabilities provide a more real-time and efficient way to keep track of everything.
Exactly. Chubby's caching is much smarter and more dynamic. It avoids unnecessary lookups and ensures that everyone has the most up-to-date information about server locations. It's like having a super efficient phone book that instantly updates whenever someone moves or changes their number.
That's incredibly clever. I never would have thought of that. So this seemingly simple lock service ended up revolutionizing how Google manages its internal network. But I imagine building something this complex, even for brilliant Google engineers, must come with its share of challenges, right?
Oh, absolutely. Building a system like Chubby at Google scale, where even a tiny glitch can have major consequences, definitely had its fair share of headaches.
Okay, let's talk about those headaches. What were some of the biggest challenges they faced?
Well, one of the biggest hurdles was actually the developers themselves.
Oh.
It sounds strange, but many developers assumed that Chubby was simply infallible. They built systems that relied on Chubby being up and running 100% of the time without any room for error.
So they built these systems on a foundation of faith in Chubby's perfection.
Exactly. It's like building a house on a foundation of sand. It might look good at first, but any tiny shift can bring the whole thing crashing down. And even the most robust systems like Chubby can experience occasional hiccups.
Ouch. Sounds like a recipe for disaster. What else tripped them up?
Another issue is storage. Remember how we mentioned that Chubby can store small amounts of data?
Right.
Well, some developers tried to use it for storing large files, which it was never designed to handle.
Ah, so they were trying to fit a square peg into a round hole.
Precisely. And as you can imagine, that led to all sorts of inefficiencies and issues. It's crucial to use the right tool for the job. And Chubby, while incredibly versatile, isn't meant for everything.
So they were basically pushing Chubby beyond its intended purpose.
Yes, and it highlights a really important lesson. Building robust systems isn't just about the technology itself. It's about understanding how people will use it, anticipating potential misuse, and designing for those scenarios.
It's like parenting, but for software systems. You have to set boundaries and anticipate that people, even brilliant engineers, will sometimes try to push those boundaries.
That's a great analogy. And speaking of boundaries, another challenge was that developers sometimes fail to grasp the distinction between a service being up and a service being accessible. Let me explain.
Okay, I'm listening.
The global Chubby cell, the core infrastructure of the system, is incredibly robust. It has replicas spread across multiple geographically diverse locations, making it highly unlikely to go down completely. It's like having backup generators for your backup generators.
Wow, that's intense. So it's practically invincible, right?
Well, almost. While the global cell might be up and running, it might not always be accessible to a specific client. Imagine there's a network outage in a particular region. The global cell is fine, but clients in that region can't connect.
Ah, so even with all those redundancies, there can still be points of failure outside of Chubby's control. It's like having $1 million in the bank, but no ATM card to access it.
Exactly. And this is where things get even more interesting, especially when you consider how people tried to use Chubby for very specific types of locking. Well, some developers tried to use it for fine-grained locking, like managing access to individual records within a database. Think of it like trying to use a giant padlock to secure a tiny jewelry box.
Yeah.
It works, but it's not very efficient.
Right. I can see how that would be a problem. So what happened?
Surprisingly, it turned out to be less of an issue than we anticipated. You see, developers quickly realized that for optimal performance, they needed to reduce communication with Chubby, not increase it.
Yeah.
This often meant finding clever ways to implement coarse-grained locking instead.
So instead of micromanaging every little detail, they figured out how to group things together and manage access at a higher level.
Exactly. It's like optimizing your grocery shopping trips.
Yeah.
Instead of running to the store every time you need an ingredient, you plan ahead and get everything at once. It saves time, resources, and a lot of unnecessary back and forth.
That makes a lot of sense. Were there any other surprises when it came to how developers used Chubby's API?
There's one design choice we might reconsider in hindsight.
Oh,
The way we handle canceling long-running calls can sometimes limit the sharing of open handles. It's a bit like having a single checkout lane at the grocery store, even though you have multiple shopping carts full of goodies.
so it creates a bottleneck where there doesn't need to be one.
Right. We might add a separate cancel function in the future to avoid those bottlenecks and allow for more flexibility.
Interesting. So we've covered the unexpected ways Chubby was used, the challenges of building it at scale, and some key lessons learned. But before we wrap up, I'm curious, what about the future? What's next for Chubby?
Well, one thing that continues to fascinate us is the interplay between the Chubby protocol and the underlying transport protocols. You see, we use keep alives, which are essentially regular heartbeat messages for both refreshing sessions and transmitting data.
Right, so you're multitasking with those keep alive messages. Efficient, but potentially tricky.
Exactly. And it turns out that relying solely on TCP, a common transport protocol for keep alives, can be problematic during network congestion. TCP's built-in mechanisms for handling congestion don't always play nicely with Chubby's time-sensitive session leases.
So it's like trying to have a real-time conversation over a walkie-talkie that keeps cutting out.
Exactly. To address this, we started using UDP for keep alives. It's faster and less affected by congestion, but it lacks some of TCP's reliability features. So we're sacrificing a bit of reliability for the sake of timeliness.
That's a tough trade-off.
It is. We're actually exploring adding a separate mechanism for transmitting data that would rely on TCP while keeping UDP for those time-critical keep-alive messages. It's all about finding the right balance.
It sounds like building a system like this is an ongoing evolution, always tweaking, refining, and adapting to new challenges.
Absolutely, and that's what makes it so exciting.
Well, we've covered a lot of ground today. From the core concepts of Chubby to its surprising use as a name server, from the headaches of building it at Google scale to the ongoing quest for optimization. It's clear that even seemingly simple actions online, like searching on Google or sending an email, rely on a hidden world of incredible complexity.
It's mind-boggling when you think about it.
Totally. But before we get lost in the technical weeds, let's bring it back to you, the listener. What are some key takeaways you should be pondering after this deep dive?
Well, first and foremost, remember that Chubby isn't just some abstract concept. It's a real system, powering countless online services you use every day. It highlights the crucial but often overlooked importance of reliability and availability in our increasingly digital world.
Think about the last time you couldn't access your email or a website crashed. Frustrating, right? Well, systems like Chubby are working tirelessly behind the scenes to prevent those kinds of disruptions.
And we've learned that building these systems is about more than just technical brilliance. It's also about anticipating how people will use and sometimes misuse them. It's about designing for robustness and flexibility in the face of unexpected challenges.
It's about making systems that are, well, a bit chubby themselves, resilient, reliable, and ready to handle whatever comes their way.
That's a great way to put it.
So the next time you fire up your favorite app or search for something online, take a moment to appreciate the intricate dance of data algorithms and systems that's making it all possible.
And who knows, maybe this deep dive has sparked a newfound curiosity in you. If so, we encourage you to share your thoughts and continue the conversation online. We're always eager to hear from fellow deep divers.
Until next time, keep exploring, keep learning, and keep diving deep.